3-pole 120/240 volts circuit breaker is not permitted to be used as main protection in a 3-phase 208Y/120 volts power system. The reason lies in the voltage ratings and the intended application of the circuit breaker. Circuit breakers are designed and rated for specific voltage systems. Using a circuit breaker outside of its intended voltage rating can lead to improper operation, potential failure, and safety hazards. Firstly, consider the voltage levels involved. In a 3-phase 208Y/120 volts system, the phase-to-phase voltage is 208 volts, and the phase-to-neutral voltage is 120 volts. This means that between any two hot wires, the voltage is 208 volts, and between any hot wire and the neutral wire, the voltage is 120 volts. Secondly, a 120/240 volts circuit breaker is typically designed for single-phase systems where the voltage between the two hot legs is 240 volts and the voltage from either hot leg to neutral is 120 volts. This type of breaker is commonly found in residential applications in North America. Thirdly, the critical issue is that the 208 volts phase-to-phase voltage in the 3-phase system exceeds the 120 volts rating of the circuit breaker. While the 120 volts leg-to-neutral voltage matches, the breaker is not designed to handle the higher voltage between phases. If a fault occurs between two phases in the 208Y/120 volts system, the 120/240 volts breaker may not be able to interrupt the fault current effectively or safely because it is not rated for the voltage level. This can result in the breaker failing to trip, leading to potential equipment damage, fire hazards, and electrical shock risks. Proper circuit breaker selection is essential for ensuring the safety and reliability of electrical systems. The National Electrical Code, or NEC, provides guidelines for selecting the appropriate circuit breakers for different applications. NEC Section 240.85, which is relevant to the initial question, would not permit this application. NEC Article 240 covers overcurrent protection, and Section 240.20 specifically addresses the application of overcurrent protection devices. This section emphasizes that overcurrent devices must be selected and installed based on their voltage and current ratings to provide adequate protection for the circuit. Furthermore, using an incorrectly rated circuit breaker can void the product's warranty and potentially create liability issues. It is always best to consult with a qualified electrician or electrical engineer to ensure that the correct circuit breakers are selected for a particular application. In a 3-phase 208Y/120 volts system, a circuit breaker specifically rated for that voltage is required. These breakers are designed to handle the 208 volts phase-to-phase voltage and provide adequate protection against overloads and short circuits. They are typically 3-pole breakers, meaning they can interrupt all 3 phases simultaneously. The correct type of circuit breaker for a 3-phase 208Y/120 volts system would have a voltage rating of at least 240 volts. This ensures that it can safely interrupt faults between any two phases. In addition to the voltage rating, it is also important to consider the ampacity or current carrying capacity of the circuit breaker. The ampacity must be sufficient to handle the load that the circuit is expected to carry. The NEC provides tables and guidelines for determining the appropriate ampacity for different types of circuits and loads. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and temperature rating. The circuit breaker should be selected with an ampacity that is equal to or greater than the ampacity of the conductors in the circuit. It is also important to consider the interrupting rating of the circuit breaker. The interrupting rating is the maximum amount of fault current that the breaker can safely interrupt. The interrupting rating must be sufficient to handle the available fault current at the point of installation. The available fault current can be calculated using engineering formulas or determined through a fault current study. Using a circuit breaker with an insufficient interrupting rating can result in the breaker failing to interrupt a fault, which can lead to equipment damage and safety hazards. In summary, when selecting a circuit breaker for a 3-phase 208Y/120V system, it is essential to consider the voltage rating, ampacity, and interrupting rating. The circuit breaker must be specifically rated for the voltage of the system and have sufficient ampacity and interrupting rating to handle the expected loads and fault currents. Using an incorrectly rated circuit breaker can lead to improper operation, potential failure, and safety hazards. Always consult with a qualified electrician or electrical engineer to ensure that the correct circuit breakers are selected for a particular application. Ignoring these considerations can have serious consequences, including electrical fires, equipment damage, and personal injury. Understanding these principles is crucial for anyone involved in electrical work, from homeowners to professional electricians. The NEC serves as a comprehensive guide to ensure safe and reliable electrical installations. Always refer to the latest edition of the NEC and local electrical codes when performing electrical work. Failure to comply with these codes can result in fines, penalties, and potential legal liabilities. By following the guidelines and recommendations provided in the NEC, you can help ensure the safety and reliability of electrical systems and prevent potential hazards. In addition to the voltage, ampacity, and interrupting rating, it is also important to consider the type of circuit breaker. There are different types of circuit breakers available, each designed for specific applications. For example, there are thermal magnetic circuit breakers, which use a combination of thermal and magnetic elements to trip the breaker. There are also electronic trip circuit breakers, which use electronic sensors and circuitry to detect overloads and short circuits. The type of circuit breaker selected should be appropriate for the application and the type of load being protected. It is also important to consider the environment in which the circuit breaker will be installed. Circuit breakers are typically rated for use in specific temperature and humidity ranges. Installing a circuit breaker in an environment outside of its rated range can affect its performance and reliability. For example, installing a circuit breaker in a high-temperature environment can cause it to trip prematurely, while installing it in a high-humidity environment can cause corrosion and damage. In addition to the selection of the circuit breaker, it is also important to ensure that it is properly installed. Circuit breakers should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. The connections to the circuit breaker should be tight and secure, and the breaker should be properly grounded. A proper installation can lead to loose connections, overheating, and potential fire hazards. Regular inspection and maintenance of circuit breakers are also essential for ensuring their continued safe and reliable operation. Circuit breakers should be visually inspected periodically for signs of damage or wear. The connection should be checked for tightness, and the breaker should be tested to ensure that it trips properly. Any damaged or worn circuit breakers should be replaced immediately. In conclusion, selecting and installing the correct circuit breakers is crucial for ensuring the safety and reliability of electrical systems. The voltage rating, ampacity, interrupting rating, type of circuit breaker, and environmental conditions must all be considered. Proper installation and regular maintenance are also essential. By following these guidelines and recommendations, you can help prevent electrical hazards and ensure the safe and reliable operation of electrical systems. Remember to always consult with a qualified electrician or electrical engineer when performing electrical work, and always refer to the latest edition of the NEC and local electrical codes. Ignoring these precautions can have serious consequences, including electrical fires, equipment damage, and personal injury. Prioritize safety in all electrical work and take the necessary steps to protect yourself and others from potential hazards. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following lockout/tagout procedures to energize circuits before working on them. Electrical work can be dangerous, but by following proper safety procedures and guidelines, you can minimize the risks and ensure a safe and successful outcome. The information presented here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work.